Hi, welcome to 10.3, which is confusingly the second one in the series. This mini chapter is going to be about electricity in transit. Unfortunately, it's called energy in transit up there, but electricity in transit. So this is about how electricity moves through an electrical circuit. So when you see electricity passing through an environment, it usually is able to do that because it has created a full circuit, a circuit through which the electricity can move. If we look at, for example, these headphones, it's not literally sound vibrating up through the wires. It's electricity vibrating up through the wires and then interpreted by the speaker in the headphones. So there are two wires heading up each side, alright, and one coming back, so it creates this circuit. The electricity can pass up, travel into the speaker, and then back down again. Okay, so the movement of energy from one place to another, or rapidly, whether it's rapidly through lightning or more slowly through an electrical circuit, depends on the movement of an electric charge. Okay, so why do we get an electric charge? What does it mean to be charged? Alright, now this is a diagram of an atom. Alright, we have protons, neutrons, and electrons, and as we know, the neutrons are neutral, the protons are positive, and the electrons are negative. Now, technically, the book where I stole this photo says that two of these protons are missing, but let's imagine they're not. Let's imagine this is as we can see it. This is as we've got. So we've got 4 protons here, so we should have 4 plus, right? All right. Now, how many electrons have we got? 1, 2, 3, 4, 5, 6. So we've got 6 electrons. So what charge are electrons? Electrons are negative, so that's 6 negative. So that means we should have 2 negative, right? So that means we've got a negative charge on this atom here. So that's what a charged atom is. It has a charge, and this charge of this atom is 2 negative. Let's actually figure out what this should be. So how many protons have we got? 1, 2, 3, 4. So it's hydrogen, helium, lithium, beryllium. So it's beryllium. So it's beryllium, Be, 2 negative. Alright, so that's what we've got here. So what does it mean when we have such a charge? Well, in every circuit, we need 3 things. First of all, we need some kind of power supply, and that's what this is. This is what supplies the electricity. It has a battery in here, a power pack, and then it'll supply the electricity. The second thing we need is some kind of load. So this is what turns the electricity into a useful form. So this is what we have here. We have a nichrome wire coil. So this coil will heat up when you have electricity passing through it. And then the third thing you need is a conducting path. And that's what these wires are. Right? So the electricity is generated here, or taken from the power pack, passes through these wires, all right, and then through the alligator clips, and then into this wire coil here. And this wire coil heats up and then will boil the water. So this is basically a kettle is what we've got here. So the coil heats up, heats the water, and we get some kind of useful energy. So we can have our tea or coffee or whatever it is. Okay. So a light bulb is basically the same. So we would have the 3 things we need. Remember, we need the power supply. So the power supply would be where the light bulb, is fitted into. It connects to the mains power supply. All right. We have the load, which is the filament here. So this filament it heats up, but it also creates a lot of light. All right. And we have the conducting path, which is other wires that lead to the filament. Okay, so you can see that this is basically exactly the same. So the conducting path, sometimes we have this is a Van de Graaff generator, and what a Van de Graaff generator does is it creates a whole mess of static electricity. Okay, now the static electricity will pass through the path of least resistance. All right, so if this lady wasn't holding onto it, there would be path of least resistance would be through the air. But now that she is holding onto it, the path of resistance comes through her hand and then out through her hair, but also down through her legs and down into the ground. So what you can actually see here, what's happening here, is the fact that her hair is going up in all odd directions. This is the magnetic field, or so the electric field that's being created by this Van de Graaff generator. This is a map of this electric field. Okay. So, what I would like you to do is copy the blue words into Quizlet and answer questions 1 to 7. Thanks, I'll see you in class.